Okay, we're on page 347. Up on the board, I've got a problem. We're going to connect two ideas that you guys know how to do. You just have to be able to connect them and see how they work together. Okay, one is a reaction. It's balanced for you. And the other one is using the ideal gas law. So, basically what we're going to do is we're going to use the balanced reaction in which to give us a certain value that we can use the ideal gas law to find the answer. Okay, so it's asking for liters of oxygen gas. So if it's asking for liters, we've got PV equals nRT. So which variable do we need to solve for?
Volume.
Volume, okay? So I rearrange that, and so then I have volume equals nRT over P. Now this is volume of what gas? Okay, oxygen, O2. So that's volume of oxygen. So what do we know? We know the pressure, right? P is equal to 0.85 atmospheres. We know the T is 50 degrees Celsius, but we want to make it Kelvin, so that would be 273 plus 50 is 81? 323? What else do we need? We need to know R. R should be what? If we look it up, it's 0.0821. Okay, then we need to know moles of oxygen. So I kind of ran out of room, so I'm going to put moles of oxygen. We don't know, and we don't know the volume. Okay, so we got two things we don't know. So you guys, I want you to look at this. I want you to. We can find moles, so that we can find oxygen. How are we going to find moles of O2? So we want to find moles of O2. What do we know we have moles of? Toby?
Moles of iron.
We know we have moles of iron. So we know we have moles of iron, and there is, well, we have grams of iron. So we have 2.5 grams of iron. So what do we need to do to get the moles of oxygen?
Convert that to moles and then do a mole-to-mole ratio.
Right. So we got to convert this to moles and then go mole to mole. And now, then we'd have our moles we can plug in here because then we'd have this number. All right? So then what we would do is we go 2.5 grams of iron. And down here I put the molar mass of iron, which is 55.85. And then I would do just a simple mole-to-mole ratio. So I go 2.5 grams of iron. And it's 55.85 grams of iron. That's 1 mole of iron. And then I do my mole-to-mole ratio. So for every 4 moles of iron, I have 3 moles of oxygen. Then once I have that, then I will plug that in over with the moles. And then I can do my calculation. So really we're connecting two concepts. One we did just recently, last test, to determine moles of the oxygen gas in this case. So it's 0.034. So then that number goes down here.
Is that 0.034?
Yep. So then this answer goes down here, 0.034 moles. Now I can do my problem. So I just plug my numbers in like I always do with that. So this is connecting ideas with the ideal gas law and reactions. So then I just plug all my numbers in and I should get my answer. So, like 1.1 liters? Is that what you guys got? Okay, good. So that would be 1.1 liters. So if I did a reaction, and I knew it was going to take place around this temperature, I'm going to set at that temperature, I would need at least 1.1 liters of oxygen gas to be put with the 2.5 grams, and then the reaction would go. Okay, everything would be used up. Okay, what I'd like you to do to practice a couple of these, you can do them in your notes. I'm not going to really probably check them. I might just go through if you have questions tomorrow on them. But if you turn over to page 348, I'll give you a couple of these to do, and you can check your answers out on them as well. So on page 348, I'm just going to read them to you because I'm going to leave this up here for a second. So what I want you to do is 65A. And 70. That's it. 70 you can't check your answer, but I'll give that to you tomorrow. That's all I want you to do, 65A and 70. Okay? Now, you guys have a lot of time to work on these two problems, which no doubt you're going to get them done. And a review I'm going to give you. The test is on Thursday. You guys, the answers are on the review. Okay? So the answers are on the review. And then no more tests. No more chapter tests. Well, I think what we'll do in the final, I'm gonna mix it up. I'm gonna have it half lab and half tests, and then after like 40 minutes you'll flip. So you're gonna be working in the lab for, we got an hour and a half, so 40 minutes working in lab, and then when you get done with your lab, you'll sit down and take the written copy. It's like 2-page, and it'll probably be over, it won't be accumulative. It'll be over the last stuff we went through. So like from next Monday on, which is 2 weeks, we'll go through new material, and so then you'll have a quiz/test over that new material, and then you'll also do the lab, and you'll have a lab that you'll have to do, and each one will get a different solution to work on, but by then you'll know how to do it really well because we'll practice during the week. So it's unique, it's different. I want to do something different. I don't want to just sit there and give you 60, 70 multiple choice questions and 2 pages of calculations and that. I think this will be beneficial for you guys, and I think you guys will do better on that. So most of you will be. Okay? So let me go ahead and write these up here again. You had to do 65A. Page 348. 65A. And 70.
Well, I'm sorry.
Okay.